Hello, welcome back to the next video with respect to future omics basics and advanced bioinformatics video. So in this particular video, we are going to see one more example with respect to R Studio. And now we are going to perform the MSA. It's nothing but the multiple sequence alignment using one of the R package. And the name of the package is nothing but itself MSA. Okay. So here we are going to see that is MSA is nothing but an R package for performing the multiple sequence alignment. So installation for this MSA you can use for current version with respect to the MSA. Okay, that is 1:24:0. It is available in the Bioconductor. Okay, you can search with MSA in the Bioconductor link. I'm going to share the Bioconductor link with respect to MSA package so that it will easy for you all to install accordingly. Okay, so this is exactly what you will going to find if you search MSA in Bioconductor. Okay, so for installation, you have to just copy the command. It's nothing but this one, and you have to run. So we are going to run this command right now. Okay, so here you can see that it is starting. Okay, so here it is the installation of our package with respect to the Bioconductor has been started, and first we are going to install bio C manager. Okay, and once it's successfully installed, so it is done. So now we are going to run this. It's nothing but from bio C manager we are going to install MSA. Okay, so that we are going to run now. So here you can see this. So you can say as yes, A, okay, means to just update all packages, or else you can ignore with some or none. Okay, so that is a thing you can do. So now I have done as A because I need all updated packages or the libraries with respect to our studio. Okay, that's why I have tried that. So now we will wait to just get update for all the packages. It will take us some couple of minutes. Okay, so now you can see that all the particular updations has been done with respect to the packages. Okay, so it will going to tell which how many packages are updated. And now once it's done, then you can run the next command is nothing but to test the installation of MSA package is done or not. For that purpose, you have to write the command which is called as a library. That is nothing but the MSA, and we are going to run this. Okay, so there is no error, and we have run it successfully. So the library MSA is available in our particular studio. Then we have to determine that it is in which particular system, or you can say as a path, so that we can just use this particular command, that is to determine whether the file is located, and enter the following command in your R session. Okay, so it's nothing but system.file text TeXshade.sty, and package is nothing but the MSA. So now you can see it is in this particular drive. Okay, so that for purpose we can use this. Now we are actually running the particular example. Okay, and we are taking an example with respect to performing MSA in the form of FASTA, right? So a multiple sequence alignment is going to implement over here. For that purpose, we have to write this first command is nothing but my sequence file. Okay, and the file is from the system.file. Okay, and we are using an example of aa.fasta, and the package is for MSA. We are going to run this first. Okay, so it is run successfully. Now we are running the second is nothing but my sequence read AA string set of my sequence file. Okay, that's the name of the file, and it is run, and I just want my sequence from here. Okay, I just don't know what is there in my sequence, but I just want to know what is there in the particular my sequence file. So if I just run this, so you will find that there is a length of sequences 9. Okay, and this are nothing but the sequence are available. You will get the name, that is Homo sapien, rat, mouse. Okay, like this number of 9 species information, and with respect to the sequence you will find over here. Okay, so that is a length has been provided, and based on that the sequence has been given over here. So this is regarding performing the MSA. Now we are going to move ahead to just perform the further analysis. So now what we are going to perform is nothing but we have 9 sequences, okay, with respect to different species. Now we are going to perform the MSA using the tool that is the cluster. Okay, so we are performing the ClustalW to get the multiple sequence alignment. So there is no need to go in the particular website which containing ClustalW. You can directly run using R as platform. Okay, so for that purpose, we are going to run this. Okay, it's a command. Okay, use a default substitution matrix, right? It will ask you which particular matrix should be taken. So it is taken as a default, and then we are giving the my first sequence alignment. Okay, and here is nothing but the exactly the same sequence what is we have given. Okay, over here, and here you can see that the name is given, that is a my sequence file. And for that particular my sequence file, we are going ahead to get the particular alignment using the ClustalW. Okay. So now what we saw is nothing but we got the multiple sequence alignment with respect to the 9 sequences as an example. Next, what is performing over here is nothing but now that we have to load the sequence, we can run the MSA functions with the default runs. Okay, so we have used the ClustalW, and using that particular thing, we are just looking towards getting the particular sequence to align. Okay, so we are using the default substitution matrix that is done. Okay, and multiple sequence alignment has been performed. So now what we are going to do is nothing but just showing the entire alignment split over a multiple blocks of the subsequences. If we do that, so you will get the particular alignment with respect to the splitting based. Okay, and once you do that, we have the next one command which is telling about the get as the output in the form of PDF. Okay, and show name is mentioned as a none. Meanwhile, so just to get to know that what actually we will get from here. Okay, so we are getting as an output from here in the form of PDF. Okay, so here once it's done, we are running the second command is nothing but to just define. Okay, from here it's nothing but the alignment and the parameters has been defined and the output has been given over here. So using the same thing, we are going to run this. Okay, now you can see that the particular path has been defined where the pasta file format sequence has been saved. Okay, that has been given over here. And after once we do, we are going to run one more command which is shown as a functions for multiple sequence alignment in more detail. Okay, we are using again the ClustalW for alignment, and we are going to just see that what actually we will get as an output. Okay, so here it is using definitely a default matrix, and we are just running this. Okay, and then we are using one more different alignment tool which is called as a ClustalOmega, right, for multiple sequence alignment. And for that we have a command which is called as a my ClustalOmega alignment, and in that my sequence and the particular tool has been called that is a ClustalOmega, and we are running that. Okay, so it is using a GONNET algorithm to perform the particular alignment. Okay, so here you can also write the particular command which is called as the that is nothing but the my sequence or the my ClustalOmega, like this. Okay, this is the one you can write. The next command, copy, enter, just paste that and run. Okay, so we got the next sequence with respect to using ClustalOmega as a multiple sequence alignment. Now we are using muscle. Okay, so muscle is another one tool to perform the multiple sequence alignment. So this is recognized, and then now we are calling the multiple sequence alignment with respect to muscle. So this is how you can perform the particular alignment using different number of tools like ClustalOmega, ClustalW, and Muscle using the package which is called as the MSA in R. Okay, so this is what we saw with respect to the multiple sequence alignment using R Studio.